Welcome back, everybody. I'm Kathy Resnichek.
And I'm Richard Pressler.
And we're here today to talk about our second assignment in our Module 3 in our wired networking course through TapdVCOE. And the second assignment in this module has to do with Layer 2 Ethernet QoS mechanism. That's a mouthful.
It is, I know.
So can you break that down for us a little bit?
Absolutely. So essentially this assignment as well as the fourth assignment in this module are all focused on quality of service. And as we mentioned in the introduction, quality of service really has to do with what does the network do when there's congestion, right? So at layer 2, we have some things we can do when there's congestion on the layer 2 network. And they have to do with specific bits that are set in a priority field. So we're going to talk about the priority field in this assignment and how to use that field in the Ethernet protocol, specifically the 802.1p portion standard.
Is that the priority? The P for
P
priority?
is priority, yes. That's finally some letter lined up with something. But essentially it's a byte that can be used, the bits within that byte can be used to determine whether or not a frame is more important than another frame. And so this is a good introduction to the concept of quality of service because the videos that are in this section, they talk about how to classify traffic. In other words, how to identify the traffic that you consider to be more or less important. And then how to mark it. In other words, how to set the Ethernet frames so that when you send the frame to the next switch, he knows what the classification is already. He doesn't have to reclassify it. And then how to prioritize it. And we've mentioned before why this is important, but just to reiterate, if you're having a phone call on a network, for example, and your computer is, for example, plugged into that phone, right? And you're having this phone call on your handset, and meanwhile on your computer, you're just randomly surfing. You wouldn't want that random surfing to affect the phone call, right? The phone call should be clear. And also there's some other things happening with a phone call too. The protocol in use for most of that kind of real-time communication is UDP, not TCP.
And UDP is?
It's the user datagram protocol, but more importantly, UDP is a protocol that does not have the concept of a session. So when a packet, a UDP packet is lost, it's gone.
It's gone.
It doesn't get retransmitted. In a video call, you would see that as like a fragment that kind of froze. Have you ever seen that, where it kind of freezes a little bit, and then it'll resume? Those are lost packets. In a voice call, it'll be gaps in the conversation, or it could sound a little robotic, you know, because there's loss, and the phone itself is trying to make up for the loss by just averaging something between two packets. But it never receives that packet again. And you wouldn't want it to. If it retransmitted the voice, that would sound like echo.
They'd be jumping on top.
It wouldn't make sense. So you wouldn't want it to. But it's important to design the network so that those packets are not lost. If they're not lost, then everybody feels that there's a good quality on the network.
Quality of service.
Compared to other protocols like surfing the internet. If you're surfing the internet, that's TCP. It's specifically the HTTP protocol or HTTPS protocol, but it's running on top of the TCP, Transmission Control Protocol. In that protocol, if a packet is lost, both parties identify that that packet was lost and they ask for it to be retransmitted. So you can be browsing a website and packets could be lost, but it still looks okay. It doesn't have any weird artifacts. There's nothing, because the underlying protocol is requesting any lost packets to be sent again. So if you're going to drop a packet in a situation of congestion, maybe a TCP packet wasn't a bad idea because you know that everybody in the conversation is going to retransmit, so therefore they're going to be all right. They're going to be okay. It has a mechanism in the protocol to just handle that, whereas your UDP traffic just doesn't. So that's some of the things that you can do with the Ethernet quality of service mechanism.
So I know some of this sounds kind of complicated, but I also know that this is already Module 3. So we've gone through a lot of this stuff, and everybody should be right on track with learning this.
We hope. I mean, it always helps to contextualize things a little bit. So, for example, way back in Module 1, we talked about switches and routers. And one of the things that helps to understand what we're talking about now is talking about how much memory switches and routers had. You learned a little bit about buffer space on
Okay.
switches and routers. So in a switch or a router, they can basically allocate packets into specific buffers. And based upon those buffers, they can choose whether to release a buffer before another buffer. And that's part of the QoS mechanism, is after you've classified the traffic and marked it, well, now you need to treat it special. And to treat it special, you could put it in a high priority buffer that gets emptied first before the low priority buffers. So now your voice call, those packets are not lost because they're put into a, you could almost say like a lane of the highway, like
Right. An HOV lane.
like an HOV lane.
There you go.
And so they're not lost, they're given a more direct path. And also they can be delivered first, which is important in some protocols. For VoIP is a great example.
Right.
Because if it lags too much and there's too much variance, it's called jitter.
Yeah.
And at some point, the phone will just start throwing the packets away
Yeah.
because they're too old. They're too far out of
okay.
sequence. And so it's important to try to keep the network delivering packets at the lowest latency possible for that particular protocol.
Great. So everything builds on itself.
It does, yeah, it
That's
really does.
great.
Understanding the buffers that are built into
Yeah.
the switch now will help you understand how you can apply rules to the packets or the frames so that they fit into specific buffers within that switch.
That's awesome. Thanks.
You're welcome.